Hello everyone, welcome to FIT 504 to week 9. How you guys doing? Any challenges so far with your assignments or lab work or anything? Nice. Nice to hear that, Cesar. That's good. Same for Harsa as well. All right. So for this week, uh, before students might join in, we'll be learning about Docker. This is prerequisite for the coming weeks. So anyone knows what Docker is? It's a big buzzword in the market at the moment. So if you say Docker, there will be a lot of job opportunities that gets open for you guys. So remember that. So yeah, customized development environment. Cesar says containerizes our executables. Yeah, Cesar, you are to the point. And Harsa, well, it doesn't customize your development environment. It makes application developer independent. Sorry, environment independent. So just like you have an image and you can run it in your Docker host. You can run it in any other Docker host. It will run exactly the same. So it makes environment independent. All right. So we just have 10 people participants at the moment. That's lesser than number of folks in the lab yesterday. No worries. All right, we'll kick off. There will be a lot of content we discussed in yesterday's lab, might be similar because we are running the lecture later. So, but feel free to have your interests ignited because there's a lot of things to learn and there might be some repetitions as well. So, right. This week is about introduction to Docker. This this is a stepping stone for the coming week, week 10, where you'll be building a Spring Boot application and Dockerize that as well. So you don't need to submit anything in week 9, but you have to submit week 10 deliverables as your weekly task. Cool. So last week, this is a bit old, but yeah, from my memory, last week, week 8, we covered Spring MVC and did the CRUD operation with it's a Maven project with Apache Tomcat as the web server, MySQL as the database server, and using IntelliJ. So I hope everybody has submitted their week 8 tasks, or anyone still pending. So last week was week about Spring MVC, and this week we'll understand a few concepts related to Docker, and then in the coming week we'll have how to use Spring Boot for enterprise applications, and then So these two parts is for, this part is for the coming week, for week 10. This week is just an introduction to Docker and how to Dockerize your Angular application. Okay, so when I say Dockerize, what does that Dockerize verb means? It means to create an image out of an application. Now you might be thinking, what is this image Sunil is talking about? Well, we'll come across that. What is that? But this week, the entire focus is on understanding Docker, getting yourself familiar with Docker commands and terminologies related to Docker. So in the coming week, we'll build the Spring Boot application and Dockerize the Spring Boot application. All right. So Docker. So what is Docker? Anyone? Cesar said something. Containerize our executables. Harsa said, okay, it makes environment agnostic. The image runs environment agnostic. What else? So Docker is an open source. So if you see, Docker is an open source platform for developing, shipping, and running your application. In essence, it containerizes your application. That means your application has everything, the image has everything that an application needs to run. That includes your code, required libraries, and binaries, and all environmental variables, whatever. So Docker enables you to separate your applications from your infrastructure so you can deliver your software quickly. With Docker, you can manage your infrastructure in the same way as you manage your application. By taking advantage of Docker methodologies for shipping, testing, and deploying code, it becomes quicker, and you can significantly reduce the delay between writing code and running it in production. Okay. In essence, what Docker does is it is a kind of virtualization. It doesn't virtualizes a system, it virtualizes an application in a runtime environment called as container, and the image, which is an executable package. Uh, so Dockerization means creation of an image from your application code and binaries and libraries into um, into an image. So you have your application binaries and libraries, and virtualizing your application. That means packaging all your application code, required libraries is into an image is Dockerization. Now, when you Dockerize an application, you basically create an image, and when you want to run an image, that image becomes a container. So I hope you understand the frugalities of the terminologies pretty well here. So one is creation of an image from libraries, code, and environmental variables and configuration file. So image is created. So you basically Dockerize an application, you create an image, and then when you run that image, it becomes a container. So basically containers are the one which is running an image. So there are two kinds of virtualization here. One is um, creating virtual machines and virtualizing your application. So Docker is virtualizing your application. It doesn't create virtual machine. So when Docker makes a virtualization, it creates a runtime environment called containers. So containers, they run on the operating system inside a Docker host. So they share the same kernel of the host machine. So containers, they run inside an operating system in which Docker daemon or Docker host is present. So your containers run inside a Docker host, and Docker is where Docker is installed. That machine is your Docker host. So you can have a virtual machine and install Docker in it, and then that virtual machine can run containers. So it can run containers, not a single container, whereas a virtual machine has one operating system. So virtual machine is a full-blown operating system with a virtual access to host resources through a hypervisor. So hypervisor, so there are a few terminologies which you may not be aware of. So there is something called as bare metal. Bare metal is your hardware that consists of CPUs, processors, memories, disks, and everything. And a virtual machine is basically that uses out of that stack of bare metal a few processors or CPUs and memory. Basically, when you create an EC2 instance, EC2 instance is Elastic Compute Cloud. That is a virtual machine. So when you create something something in your cloud, that is a virtual machine. So your virtual machine has its own operating system. So when you create a virtual machine, you specify what operating system you're going to run in. However, when you have a virtual machine and you install Docker in it, so Docker shares the kernels with the Linux kernels with the host machine. Okay, so in that way, when you run an image in a container in Docker host, you actually run a container inside Docker host, which is a virtual machine. And you can run 10 containers, 12 containers, n number of containers, but there is one operating system in there. So if you look at this diagram here, so you have the bare metal infrastructure, and this is a VM. So you're running Docker in the VM. So Docker, so once you install Docker, this VM becomes a Docker host. And then you can run n number of images or even the same image n times. So in that becomes, you can run multiple containers inside Docker. So the one major reason why people are moving to Docker is, yes, Harsa did say that it makes development environment, it makes application environment antagonistic. So you don't have to worry about the environment. You can transfer your code in an image from dev environment to staging, from staging to production without any hassles. All right. That is one. Second is once your application code is containerized, you don't have to worry about your environment variables because they're all inside your image. Image contains everything that an application needs in order to sustain itself and run independently. Another reason why Docker is used because it makes shipment of code and the readiness of the code for deployment and production faster. Another reason is because it improvises the utilization of CPU resources. Just a second. All right. So why? Because when you're running one single application in one VM, your VM CPU, memory, and all, they may not be optimally used. But when you're running a Docker, Docker actually Docker daemon itself is very lightweight. It's just a process. Um, all memories and everything that takes is basically the running instances of the image. So when you have when you can run multiple containers, you can basically stack in everything to make use of your VM. So you, when you're paying for your CPU, you basically using 100% of it. You're paying for the memory, you are trying to use all possible memory level. So this is these are the reasons why people are moving more towards Docker. So this is a VM. So you have the bare metal and a hypervisor runs on top of it, and you create a virtual machine. Okay, so virtual machine has an OS, uh, OS binaries, libraries, and application install. Whereas in Docker, between OS, after OS is installed, when you install, you want to make this VM a Docker host. What you have to do is, after installing the OS, you need to you can have your binaries and libraries. You can have your Docker installed here, and then have your application run inside your Docker. So this is the primary difference between a virtual machine and a Docker host. Okay. So primarily, if you see this, the containers, they run natively on Linux, okay, and they share the kernel with the host machine. So as a thing, Docker is actually built for your Linux machines, Linux kernels. So for people, those who are using Windows for your assignment or other work purposes, I need to share you something. Um, so hmm, so I put it in a chat. So um, Bash shell is one of the shell that bone only shell. That shell directly interacts with your kernel, but if for Windows, there is nothing as such to run Docker natively. However, from 2016, Windows has created something called as WSL, Windows subsystem for Linux. So if your operating system is Windows Pro, or your operating system is uh, Windows 10 Pro or Windows 10 educational version, and your hardware supports virtualization, only then you will be able to run Docker in your Windows environment. Okay, so if you don't have these two things, you may not be able to run Docker. So so two things: you need to have Windows 10 Pro, and your system needs to support virtualization, or you need to have an education version of Windows, and your system needs to support virtualization in order to run Docker in Windows. However, you can always install a Linux operating system like Red Hat, Ubuntu, Fedora, CentOS. CentOS provides a very good OS, the UI, so you can use any of these operating system, and there you can install Docker and practice. Okay. Because in production environment, most of the servers, they're Linux servers. Very few systems you'll get where you have Windows. However, for the people who are using Mac, it's a good news that Mac uses Linux kernel. So Mac is built on top of Linux kernels. So the native Mac OS, they interact directly with the Linux kernel. So basically the commands that you can run in Linux is a similar kind of commands you can run in Mac. Okay, one more thing. For the people using Windows, you need to install this. You need to download this and install. So try it out. If you are able to run, if your operating system supports, then it's good. If it doesn't support, then these are the two choices I said. So this is the choice that you have. So for the people using Windows, there is something called as git bash, which is actually the first link, git for Windows. So if you go here and download and install this, you should be able to see and run git bash. So you don't need to use the GUI because it has something called shell integration. So you can use the git bash, which looks something like this. Okay, you don't need to use this. So it will open up. So you'll see something similar to this. Okay, and a git bash. But for Mac or Linux user, it's very simple. Just use your terminals. They are your best friend. Okay. All right. So this was about Docker running in Linux, and for the people to run Docker and install Docker CLI, you can check if Docker is installed or not by just doing Docker -v, and it will tell you if you have Docker installed or not. Okay, so once you have Docker, so this is Docker CLI. So CLI interacts with Docker host. So once you install this thing, your local host, wherever this is installed, it becomes a Docker host. So you see there is nothing up here. So once I run my Docker daemon, whatever I have downloaded here, once I run that, now the Docker process is starting. So once it starts, my system is now a Docker host. Cool. So we go to the slides back. So let's look at some more terminologies. So you have a Docker daemon. It interacts. It has a REST API through which your CLI can interact with. Okay. So when you run a Docker command, basically you're running CLI, command line interface. You're using the command line interface and passing the commands, and they interact with your Docker daemon. Okay. So this is your Docker daemon. I'm starting it for my convenience and to show you this something. So when you have a Docker container image and everything, you can manage your own network. You can manage your containers and images and different data volumes. Data volumes are the one where you have data stored inside an image, all right? Or you're using an image to interact with a database. So these are four major aspects of Docker client and the Docker engine. So this is like client server application, a Docker daemon, which exposes a REST API, and you're using a client. So when I use this terminal to run some command, basically it interacts with the Docker host Docker daemon and returns me all the result. All right, so this is Docker CLI, and this is now it is ready. So this is Docker uh, host. So because I'm running it in my local host, my local machine is the Docker host. Okay. So basically you have this is the Docker. So once it comes up, you'll be able to see. Click on images. You can see different images. There are a few images that some years old. So I'll just remove the one which is not required. But there are ways to remove it. I'm just clearing up some space for demo purpose. Right. So this is your Docker architecture, your Docker client. Uh, so this is your Docker client, and my local host is the Docker where Docker daemon is running. That is Docker host. Currently, there are no containers running. And so once you have an image and you run that image, that image becomes a container. So images are stored in a registry. So this is Docker registry, which is called as Docker Hub. So if I open Docker Hub, so this is the place where you store images. Docker Hub is basically a registry. What is registry? Registry is basically a repository where you can store your images and version control them. So here you'll have a lot of images from different organizations. Right. So this is Docker Hub. There is another registry available in Amazon environment, AWS environment, which is called as ECR. We'll see that in week 11, okay, in cloud deployments. So registry is where your images are stored. If you build your image locally and do not push it to the registry, they will be stored in your local. So even when you do a pull an image from the registry, they will be stored in your local. So when you were seeing these images, right? These images are present in my local. So so Docker Hub allows you to have only if you're not an enterprise and not paying up, you can have only one private repository here, and any other repository you want to push it here, it has to be public. All right. So that's why only the enterprise, they buy private repositories for their work. Cool. So the client has majorly three commands: Docker pull. So when you do a Docker pull, it basically, the Docker daemon will see if you have that image in the local or not. So if you have that image in the local, then it's fine. If you don't have the latest one in the local, or the version that you have requested for in your pull command, if it's not there in the local, it will interact with the registry, find the version of the image that you requested, and it will download it into your local. So that's the job of Docker pull. Okay. So these two things, Docker build and run, uh, they're quite similar. It's just that your run command can also build and run. Build is you have the newer version of Docker. They do support a command called create. Docker create or Docker build. These two commands, they actually create an image. All right. So they create an image, and what that image contains. Image contains code, binaries, and libraries, and all environment variables, whatever your application need in order to uh, create your containerize your application. So build creates your image. So when you run this build command, it will consume a Docker file, a file that has a name, Docker file. Basically, this file, Docker file, contain instructions how to containerize your application. So this will create an image. This is used to pull an image from the registry to the local, and run is used to run the image in the Docker host. This is a Docker architecture. So Docker is a kind of virtualization, application-based virtualization, not infrastructure-based virtualization. All right. So when it is an infrastructure-based virtualization, you create a virtual machine. When you have application-based virtualization, you create a Docker image. All right. So this is the one that we were discussing about. So Docker client talks to the Docker daemon, which does the build, run, and distribution of Docker containers. Both client and server can run on the same machine. Docker registry stores the Docker images, similar to Docker Hub. Only difference being the registry is in your local PC. So the images that you build, it will be in your local PC. Once you have your account created and then publish it, only then you can create push your image into the registry. Right. So we'll show you how to do that when you're in your AWS environment, because Docker Hub supports just one image. I won't be able to show you everything with the Docker registry, but yeah, you can create your image and have it in your local. Right. So what is Docker images? These are read-only templates with instructions how to create a container. Always remember, images are read-only. Okay. Uh, so images are based on another image. So you can have one image and then you can customize and build another image on top of an image. We'll see a lot of examples of what I'm saying right now, building images on top of image. In fact, every instructions that goes in Docker file actually creates one layer of image, and then the next command will create one more layer of image, and then the next command will create one more layer of image, so on and so henceforth. So at the end, what you have, the final image, is basically the final output of the Docker file. So you create your own images by creating a Docker file. So you use Docker file to provide instructions what to do in order to create your own image. So Docker uses layering. So each instruction in the Docker file will create a layer. Only layers which have changed are rebuilt. Hence, making Docker lightweight, small, and fast. So if you have a Docker file and you have 10 different lines, so there will be like 10 different internally images are created. Okay, but at the end, the output is one single image. So if you change only, let's say you change the 8th line of the Docker file and you rebuild your Docker image, it will not create a step 1 image, step 2 image till step 7. It will reuse the image from step 7 and build another image on the latest changes in line 8 on top of it. And then line 9 and line 10 will add on top of it. So this is how it reuses. So only the layers which have changed are rebuilt, hence making Docker lightweight, small, and fast. So this is about images. So images are basically your application virtualization. Next is containers. Containers are the runnable instance of an image. So you can create an image, create a container by running an image, start a container, stop a container, move or delete a container using Docker CLI. You can also attach containers to network and storage by mounting different host directories inside containers. Those are little advanced stuff we are not doing in the introduction lab, but yes, uh, in the next week 10, you will be having some information about to use Docker Compose. So one is Docker and another is Docker Compose. So we'll be using Docker Compose, where we'll specify different networks to use, storage and the mount points, the host directories to be used inside Docker. All right. So containers, they when they run, they have their own directories and path, and you can access it from the root and everything. I'll show you while actually giving the demo. So containers are isolated from the host machines. So the root of the container is not root of your host. So containers are run independently inside an host machine. So when a container is removed, any changes made to its state is not persisted. So if you have something stored inside a container, and then when you stop and remove it, that part of your data which you have saved, it's not saved in your container. Once it is removed, it is removed. That's why persistence uses something like databases and everything. So you need to have some kind of other thinking how you can do that. You can do that using mounting host directories, and we'll demonstrate that in the next week in Spring Boot example, when we Dockerize the Spring Boot example. All right. So what the last two lines means is if you have locally stored anything, it will be removed when you remove a container. So if you have anything to store, you need to store it in a persistent state in a database. Okay. Right. Related to Docker services, The scale containers across multiple Docker daemon, which work together as a Docker swarm with multiple managers and workers. So um, this is a little advanced area where you have multiple Docker containers running inside a host, and maybe in multiple hosts, and they share a same load balancer. And that load balancer usually looks after the number of requests coming in, and then scaling up the number of containers depending upon some metrics like the host CPU usage or memory usage. So if your Docker container is the usage of CPU and memory allocated to your Docker container is going high, it can monitor that metric and you can create one more container. Well, this is again the next part of it, which probably we are not covering. But yeah, this comes under load balancing and usage of multiple nodes, which is called as Docker Swarm. So this is what you define a desired state of your service. That means you want when you see that your requests take a longer time, in order to make it more available, you change your application into microservice pattern, containerize them, and run n number of containers, increase the scale of number of containers based on the load balancers sticky sessions, and then scale down based on the metrics that you have defined. Basically, when you have Docker host CPU usage going high or low, when it is coming low, you can kill some of the containers. But when you see that you need more hosts or more nodes, more containers, you need to create or scale up the number of running instances. So usage of container, this is one of the advantages of using containers, the scaling of an application in an enterprise environment. Scaling of an application is seamless when you use containers. Okay. One of the major advantage of using Docker is containerized application can scale up and scale down based on a single metric or a combination of metrics. That's one of the reasons why Docker is very popular. Right. So then you have Docker namespaces, control group, union FS. Docker uses technology called namespaces to provide isolated workspaces. When you run a container, Docker creates isolated namespaces for that container. Docker engine also relies on control group to limit an application to specific set of resources. This allows Docker to share available resources. Docker leverages a union file system, union FS, that operate by creating layers. So I was saying, so when you have multiple instructions in a Docker file, it creates read-only layers of images. I think I just explained you the same thing before, right? Creating images. So it's so which file is used to create images? Good. And which command is used to build images? So it's Docker build to build images. So To build an image, you need to locate the resources, what can go into that image. So image defines what goes in the container. Basically, you need to access some of the resources like networking interfaces. In Linux, you call them as ENI, elastic networking interfaces, EN0, EN1, likewise. And then disk drive is virtualized inside your environment, which is isolated from the rest of your system. So maybe when I run a container, I'll show you what's there inside. And then you have something like the source code, which you need to build the executables. So you need them inside the image, and you also need to decide on what port you need to expose from the Docker, so that those ports are exposed to the outside host. Uh, so when a Docker image is running as a container, so the container is exposed on one. So let's imagine this as my Docker host, and it is inside a local virtual machine. So in the virtual machine, you are making a request to, let's say, 8080, which is localhost web request port, and you want to map that to Docker host 8080. In that case, you need to specify which port that you want to expose your Docker image. You need to specify that in your Docker image. So it maps the port to that outside world. So from the Docker host to your local host, these ports are mapped to each other. It also specifies the startup command for the image. So the last line of an image should be what starts up that image. So uh, when you run an image, it's basically the last line of that image which actually starts up that image, basically an executable command that executes or runs that executable image. So if you look at this Docker file, this is something similar to what you will be using in the coming week, where you will be saying, okay, I need Java 8 in my image. So when I say Java 8, what it will do is when you run this command, Java build command, it will look if you have Java 8 in your list of images. Okay, if you have that, it's good. If you don't have it, what it will do, it will, the Docker daemon. So Docker daemon will look for the local images. I have it, but if I don't have it, what it will do, it will contact the registry. So this is my registry, and it will search for something called as Java. So when it looks for Java, so Java has many versions. So there will be some versions here. Okay, so tags are the versions. It has multiple tags, so it will have some tag as tag 8. So you can specify your tag. Here I haven't specified any tag, so it will get the tag 8 one to me. Okay. And then it will create a volume with /temp, and it will expose the Docker container 8080 port to the outside world. And then this command is basically, it waits for till Docker compose command is executed. And then this one, it copies the file, the jar file which was generated to the Docker home home directory. And then this one will tell you the present working directory, and ls will tell you what files are present there. Chmod will change the change plus x will add everything in the /wait directory as executable. And then here you are running the Java jar data JPA Spring Boot application. So the last line is always an executable thing. So it specifies a startup for command of an image. So Docker file, each command in the Docker file is a layer. Docker will maintain a cache of each layer. Layers that change often has to be moved to the top so that Docker can leverage the cache to make up your builds faster. Every Docker file will be built on a base image. We'll use a from keyword. Here we have used Java 8 as the base image. Java 8 image is pulled from Docker Hub. Docker Hub is like the GitHub repository for Docker images. GitHub is like your repository to maintain source code. Docker Hub is like the repository to maintain Docker images. Add keyword is used in the Docker file to copy source file to the image. This is similar to that of your copy. Usually we used to copy the source code and other dependencies and bake it into the image. The run keyword is used in Docker file to execute commands. Example, if you were Dockerizing a Node.js app, you would build a run npm install when the Docker file is built. And then command word is used as an entry point. It defines the command that is executed when you create a container from the image. Okay, the golden rule of Docker is one process per container, or what you can say is one. It should your container should serve only one purpose. You should not serve multiple purpose in a container. So that if your container is killed or it crashes, you can always create another container. It will not affect any other dependencies. That's why you should always create based on one serving or one process per container. Right. So these are some commands which we will go through them as a part of the demo. Right. Okay. In the coming week, we will do cloud deployment. I will do the demo in after, let's say, 10 minutes or yeah. So it's 6:56. Let's come back at 7:05. 7:05, we'll have the run through the lab demos and some of the commands again. All right, 7:05. Here, Next week is not cloud deployment. Next week is Spring Boot and Docker, which is week 10. And week 11 will be cloud deployments. So the slides needs to be updated a bit. So we'll start with the lab part. I'll first familiarize you with the commands. Go one by one. So I need a terminal to work with. So this is my terminal. I hope you can see the front. Okay. So so by default, when I'm in my root directory, there could be some permission issues which I faced yesterday in my lab while demonstrating to my students. So what you do is not to use directly your home directory. So just uh, change or create a new uh, directory or a folder, call it as let's say week 9. All right, and then go to week 9, and then this is my present working directory. And then if you run docker -v, it tells you the version of Docker which is running, and then you have docker ps to show you the list of running containers. So docker ps, so I have nothing running. If you have exited a container, that's a container that just stopped running, so you want to see a list of all containers, including the ones which just exited. You can run ps-a, and then you have, so if you have a running container, you can do docker stop, pass the container ID or the container name to stop it. And then to see the logs being created by the container ID, you can write docker logs container ID. And to run an image, it's docker run. We'll do some of those, don't worry. So docker pull image name. So if you want nginx from the docker hub into your docker local docker host, what you do is just say docker pull nginx. So when you say docker pull nginx, it'll come to the docker hub, look for nginx. So nginx is also a web server. There are multiple usage of nginx. Actually, you can use it to load balance or do a load balancer as well. So in all, it's an very lightweight um, reverse proxy server for HTTP, HTTPS, SMTP, POP3, and IMAP protocols, as well as load balancer and web server. So we'll be using the web server part of it. So for web server part, it serves all your web pages content present, the static web files present under user share nginx HTML directory. And to configure it as a reverse proxy or something else, there are some other commands that you need to do, right? So if I want this, I'll have to copy this and put it in my terminal if I'm lazy to do. Now, if I do this, it will always pull the latest tag. Okay, so the recent version of the image is tagged as latest. If I want a specific version, I would say colon that specific version. So if I want to use some stable version, I'll probably use this. If I want to use which is very bare minimum Nginx code, and not with any extra configurations, then I'll probably use an Alpine version. So Alpine versions are the one which is used for which has most minimal configurations. So yeah, so once I run that command, in this case, I'm pulling an Nginx image from Docker Hub, the latest image. Okay, by default it is latest, but if I want a specific version, I specify the version here. Okay, so once I do that, you will see here Nginx will show up. So these are my images in the local. So it is downloading the Nginx. Right. It will take some time to download it. So now it says that Nginx is downloaded, and you can check that from check that in your local thing here, Nginx. You see latest with this is the image ID. So if you want to see that, so this web console thing, this UI, the nice UIs, you won't find it in your production environments or in your enterprise environment. All you have to work is using CLIs or command prompts. So here, if you want to see what are the images present in your local, so just do docker image ls, and it will list out all the images present. So this was the one which was downloaded recently, right? So once you download, you can see that image. And if you want to tag a specific image, so you can run docker tag command. So if I do docker tag Nginx with Nginx custom 1.0, what it will do is it will create from this image, it will create this image and tag it as 1.0. So now if I do ls, you'll see I created a custom image built from the Nginx image and give it a separate tag. You see they share the same image ID, but I can refer them with different names and versions. So let's let us build another custom image from a Docker file. So ls, there is no file here, so I'll do vi docker file. This is the one which I need to build images. So if I do vi docker file and I write there from Nginx and then save it. So if you are comfortable with Nano editor, use Nano. If you're comfortable with VI, use VI, whatever you feel comfortable. Then you do docker build with tag Nginx custom, and version is 1.1. So you're running a build command to build this image. So this image is already there, but you want to build another version, 1.1 version of this image. And when you do build, you need a Docker file. So Docker file has from Nginx, and then you need to specify where that Docker file is. So it is in my current directory. So dot is my current directory, and then enter. So now if you do image ls, you'll see all three. So this was the first image. We built a custom image 1.0, and then we use a Docker file to, so this is when you did a tagging, okay? And then this is when you build an image from the Docker file, okay? Now we'll create a simple web server serving static files. So for that, what I will do is, I have already got Nginx latest in my local. So I will edit the Docker file. So here, if I do clear ls, so I have a Docker file. I'll create an index.html file, and I will copy this content. So this is to serve a static web page containing hello from Nginx to students of FIT 5042. And then I save it. And then I open my Docker file. And I say, create an image from Nginx. And then what you do is, to serve the static files, you copy the index.html that we just created and paste it to user share Nginx HTML. So a few moments back, I was showing you Nginx can act as a web server, and it shares the static content under this folder. So I'm just copying my static HTML directory, or currently for demo purpose, just a file to this directory. Once I do that, so my Docker file is ready, and now I will create a new image. I'll call it as Docker build an image, tag it. So it's 5042 Nginx. You can give any name. So whatever name you will give, that would be the name of the image. So I'll just call it as v1, and from the Docker file in the current directory. So if I wanted to give a okay, there was a typo there. I said bill, not built. So if I don't provide anything under colon here, in that case, sorry, anything in colon here, by default it will create a latest image. But if I say it's v1, then the tag will have v1. What? Docker. Oh, it's built, my bad. All right, so Docker Control C, clear. So Docker build this image with this tag from the Docker file in the current directory. Enter key. So this step becomes very fast because this is already present. It is maintained in a cache, and then it uses this image and then builds this image, and the image is built successfully. So now if you do Docker images list, you will see this new image, what we created of the tag that we wanted was built here. Okay. So if you want to run this, you can run this image. So to run, you need to have docker run command. So and then provide the name of a container. The name of the container can be the name anything. Okay, you can, if you don't provide a name, it will provide interesting names actually. And then -d is saying that run this in the background, and which image to run. This is the image, and if you have a specific version of the image, you can specify this specific version of the image. So when I say run, now this is successfully running. How to check the containers running in my host? Which command? Docker ps. Very good. So when I do docker ps, now you will be able to see I have a container running. Okay. And the container is listening in the port 80, but it is not exposed or mapped. What port from the local host is mapped. So this is your container is listening in port 80, okay, but not your local host. So local host, you are running in local host 8080, but it doesn't know Docker is running in 80. So if you say 80, basically the local host is not running any process that is listening on the port 80. So what you have to do is you need to specify host, which port of the host is mapped to which port of the Docker. That you can specify using -p. So yep, -p. So for that, what you have to do is quickly stop this. So docker stop. You can provide the name of the container. So you can provide this as well. Or as I prefer, always use a container ID. So docker stop this, stop the container, and then docker. So you can. So once it is stopped, if you do docker ps, my bad. There's nothing running, but if you want to see what exited recently, okay, this exited 18 seconds ago. Now you can do docker rm that container ID. Okay, now there's nothing in there. So we have that image. We need to run that in a proper manner. So what I do is I will run in a different name. Let's say v1. You can give any name, okay? And then I'll say map the local port 8080 to Docker port 80, and then run it in background, this image, this version. Okay, now when it is running, you can go to localhost, and in the localhost, you look for 8080. You will see hello from Nginx to students of FIT 5042. The static web file which we presented is actually coming out from that container. Now, if you want to, if you're a bit interested and want to know, okay, how, what is there inside that container, you can actually run few things. It's not there in the sheet, but yeah, you can run Docker. So for that, you need to see what is running. So Docker ps, I have this container running. So if you do Docker execute it provide the container ID, and I want to so basically what it does is like it will execute whatever command you pass uh, here in the container, in this specific container. So I'm interested because I copied this file in my local to this directory, right? So uh, I'm hoping that this file was present inside this directory. So I'll say cat open me from so this is inside the Docker container. Okay, uh, cat open me this folder and index.html present inside it. So you'll see the content. Whatever we had it in our local is actually present inside Docker this path. So this is one way of seeing what is inside the container. But if you want to go in a subcell into the Docker container, so what you can do is instead of displaying that in a cat command, what you can do is you can do bash shell. It will open up a bash shell. So this is you're inside the container as a root, and then this is your present working directory. This is not your user root. This is inside the container root. So if you do cd this directory and then ls, you see this file was copied from the local during the creation of the image and being transferred to this directory here. All right, so now if I exit, I come out to my present working directory. So this was for the lightweight stuff. Let me clear this out. Now, if you remember your week 6 where you created your Angular application. So just give you a few things for the people who are listening. Even if you keep your expertise after completion of the course, even if you simply focus on week 6 and this week 9 and try to learn and conceptualize things and understand it and put forward yourself as a good front-end developer with knowledge how to containerize a Angular app, still you have better prospects of finding jobs in the market. All right, so this is my Pokemon app which was running from port 4200. Let's say I just run it. So we do ng serve and then it will run. So this was our Pokemon app. Now what we need to do is in task 1.3, what I'm doing is I'm containerizing this Pokemon app. What I have to do, I need to get all the libraries, I need to get the source code, and then I need a web server where I can host my static files and run them. Okay, so what I have to do is I have to simply go to the root of the directory, a root of the application project, and then right click. Sorry, my system hanged. So just right click and create a new file, call it as a Docker file, and save it. I already have that file, so this is what you got to do. And inside the Docker file, put this content. So what this content does is it gets the node library. So this node 10 Alpine is pulled from the Docker Hub. So I did close this, right? Docker PS. Okay, this is already running. So if I refresh, it will keep coming. But what I'll do is I will do Docker stop this container. So once I stop this container, if I refresh, I will not get any response. So this was running from my container. So Docker remove this. Okay. Mm. So what it will do is it will pull up the node 10 Alpine version from the Docker Hub. It will go to the Docker Hub and it will look for a node. So remember, a Node.js is a requisite for both Angular as well as React app, because ultimately whatever the HTTP commands or HTTP client that you're using, it interacts with the Node.js library. So Node.js platform is definitely required for both your Angular or React, whatever framework that you're doing. So from the node, it has all these tags. So it will just find uh, a stable tags and get that. So this 10 hyphen Alpine. Alpine basically a very bare minimal version of Node. That library doesn't stack, is not stacked up with a lot of things, and it is as builder, because we are going to use this as one part of the run set, and then this is the second part of it. So the first is it will download the Node 10 image from the repository, and then it will copy package JSON and package log JSON to the root directory of the image of the container. So when it runs, the container is running, only then you'll be able to see what is there inside that. So it will copy this package JSON and package log JSON into the root directory. What package JSON and package log JSON defines is the different modular dependencies that this application has. So those dependencies are defined in those files. So our app is running in 4200. So 4200 is where it is running at the moment. So this is your CRUD app. This is running from my local server. Now what I will do, so after it copies this into the root file, it executes npm install, because you need a node package manager, and then you create mkdir this folder. So you create app UI folder to keep all your source codes, and then you copy. So once you run the install command, all the dependencies that has been present in the package.json will be downloaded into your node modules, right? So it then copies that node modules into the app UI folder, because these are required to run these are the binaries or the libraries required to run your project. So once that is done, it installs Angular client 9, Angular 9, and then work dir. So work dir is basically CD. It is changing directory to the container root slash app UI, and copying everything which is present here wherever because this first dot is your source, right? So whatever present in your source directory, all your source code will be copied across to the working directory, to this app UI. Okay, so after that you run ng build. Ng build is to build your Angular artifact, and the path that it will be built is your working directory slash dis, sorry, working directory slash dist. So this is where your artifacts, Angular artifacts, which are the static files and everything compiled version, those are built, will be present here. Now what you do is you get the bare minimum Nginx version, that is Nginx Alpine, and copy from the builder. So from this stage, so this is the first stage, copy from the builder all your artifacts created in this directory into this Nginx static web pages hosted directory, and then you expose 80 from the container and then run Nginx command, Nginx -g daemon off. So once it runs, basically this all the static files present in these directories are hosted to the local or the host environment. So this is now running from localhost. Let me stop this server. So this is no longer available, localhost 4200. And then because I have this Docker file created, what I will do is I will build the image. So to build that image, I'll run a build command. So I'll just open up a terminal here, pwd. So I should have the Docker file in here. So ls grep Docker file. Yep, so I have Docker file here. So I'm the right directory. Now I will do Docker build -t node demo. So this is the name of the image that I'm trying to build. If I don't provide any tags, if I want to give it a tag, I'll give some tag. But if I don't provide any tag, it will be latest. And then from the Docker file present in the current directory. So it will take a while to build the image because you will see each line is one image. So this is sorry. So this is one image. This is one image on top of this image, and then after this line is executed, one image is formed, and then this image is built on top of the image built on this step likewise. So it will take a while to build. So get yourself a coffee and enjoy till this builds up. It will take a while. Is the step one started?
Sunny, can I ask a question?
Yes, please.
What's the function of the copy dot and dot?
So work directory is when you do work directory, this is basically similar to that of CD, change directory.
Yes.
So in the uh, container or in the image that you are building, it is switching your space of working directory as slash app UI.
Yes.
So when you did copy dot, that means wherever this Docker file is, the source is wherever the Docker file is. Copy all existing, because your code is under the src here, which is in the same directory of your Docker file, and it is saying copy all everything which is present under your source into slash app
Working
UI
directory.
inside the container.
Okay.
So copy source to destination.
So the first dot means the directory where doc file locates,
Correct,
and the
correct.
second dot means the working directory.
Yes, working directory where you have switched your workspace.
Okay. Thank you.
I think there will be, I'm just running the commands with some explanation. You have details of it in your lab guide. So feel free to have a look at it. So this is where we copy the source code from our local. So this is our local into the app UI folder of your container. So whatever dependencies or libraries or binaries that you need needs to be backed into the image. This building process, what you call, it's actually how you bake an image. So image should contain all dependencies. That's why the baking process might take a bit of time. But once it is done, once it is done, I can give you my image and how things run in my local. It will run exactly the same in your machine. So when I give you my code, you may have difficulty in running it because you may be having issues with your environment or some dependencies, this, that. But when I have an image and I provide you my image, uh, that image should work exactly the same. So make sure you go back and practice the commands. There are some more commands like installing MySQL database, looking into the logs of a container and things like that, which I may not have done this in the in the demonstration part due to time constraints and everything. So run this and see what happens. Um, if you're able to run the MySQL, I think there are some commands up there. So, yep. So do these things as well. This command, practice these things as well, which I may not have done. So now, um, so if you see in ninth step, this sorry, in 11th step, this image was created, right? So because this was my build command, when I didn't give any build command, by default, the tag it used was latest. So now if I make some changes and I run this again, this image will lose a tag and the new image that will be formed will have the latest. So I want to see the list of all images. So this terminal is exactly the same as that of this terminal, okay? There is no difference. So if I do Docker image ls, I should be able to see the node demo thing here. So you can see node demo, okay? This was built a moment back. Now, if I run this image, you run it here or here is the same thing. So Docker Docker run, I'll just give it a name, node demo. So you can give any name, okay? You can do node demo v1, whatever, okay? And then I say map the local port 8080 to the exposed port 80, exposed port 80. So expose port 80, run it in background, and the image that you need to run is node demo. And do I need to specify anything? No. So once I run that, oh, so once you run that successfully, you can check Docker PS, and you have node demo running. And if I do so if you see this, this is my local host. 8080 is mapped to port 80 of the Docker container. So when I run, sorry. So when I run localhost 8080, I should be able to see the app, Angular app running from the image. This is exactly the same, okay? So this is running from the container, and if I stop the container, so Docker ps, sorry, Docker stop. So just a second. Let's we have some we don't have much time, but yeah, let's try to go inside the Docker and see what it contains. Okay, let's do some surgery. So Docker exec it, and then I pass the container ID here, and then I'll open a bash shell. I'm into that container. What? Docker exe it, pass the proper name. Okay, executable found not. Okay, something wrong. Anyways, that's fine. Anyways, all right. So that comes to an end. We'll just stop the container. Docker stop, pass the container ID, So once the container is stopped, then you won't be able to get the web page. And then Docker rm this. So in this process, I might have created so I might have created so many images with so much of size, right? So this is an easy way here using this UI. I can go and remove this. So if I want to remove FIT 5042 Nginx v1, I can just simply remove here. So if I want to do it through the command prompt, what I would do is I'll get the latest image list, and now it won't be there. So you see this is not there. You can run docker rmi. Rmi is to remove an image, and then pass the image ID. So it will remove that image. So likewise, if I want to clean some more image, I can I can pass in some more image, and yeah. So this has to be forced. So if it has to be forced, then I need to specify -f. So these are like commands that you need to pass. So all these are also removed. So if I do ls, all those related ones are related to this. All three, they are removed. So once I do that, I'll have some more space here. So once I remove those images, I'll have some more space. Yeah. Okay, this is all for today. Any other questions we can take, or we are already right in time? So thank you very much. Any questions we can take? All right, thank you very much. Enjoy. Make sure you practice this because you'll need an understanding of working of Docker for the coming week. Remember, everything from every lecture is examinable except week 11, which is cloud deployment. This is just for your knowledge. Week 11 is for your knowledge, but week 1 to 10 and 12 is examinable. So even if it is not part of your assignment, don't be light and ignore it. And then when you go into an exam and you see questions, you feel some heat. So better prepare yourself accordingly. Right. Thank you very much.